Hello everyone. Today I am going to discuss about the surface area and volumes, where first of all I'll be discussing about the formulae which is related to the surface area and volumes. Then we'll be discussing the combination of solids, where we'll talk about how we can find out the surface area of combination of solids, and then following which next we'll be discussing about how we can find out the volume of combination of solids. So let's start with the topic. So first we are going to discuss the formulae. So here first we'll talk about cuboid. So in this case, if we'll take, let the length of the cuboid be L, breadth be B, and height be H. So here what we observe first of all when we talk about the surface, so a cuboid will have 6 surfaces, which is the top surface, the base, and then there will be 4 side walls. So there will be total 6 surfaces, and each surface will be of the shape rectangle. And as we know, area of rectangle and perimeter of rectangle, which is L into B for area and 2 into L plus B, that will be for perimeter. So here when you talk about the total surface area, which will be equals to, here if I'll take this one as L, B and H, then the area of this face will be L into H, which will be same here L into H. This face area will be B into H, same is here. And then the area of base will be L into B, and the top area will also be L into B. So total surface area will be 2 times LB plus BH plus HL. Here one thing we need to remember, the total surface area we can also write it as TSA. Next, when we talk about lateral surface area, which we also represent it as LSA, that means it is the area leaving the base and the top. So here the lateral surface area, when we leave the top and the base surface, we will get 2 times L plus B into H, which also can be written as base perimeter into height. Now next we'll talk about volume of cuboid. So the volume of cuboid will be L into B into H, which also can be written as base area into height. Now one more thing we need to remember here is the body diagonal or the diagonal of a cuboid. So in order to obtain the length of the diagonal of a cuboid, what we'll be doing is, we'll be connecting these two ends, as this is the longest length which can be there in a cuboid. So as we know here, the height is H, and if we'll also join these two corners, and if you will name it as A, B and C. So here the value of BC will be equals to a square root of L square plus B square, as the base is a rectangle. This angle will be 90. And then we have AB equals to H. Here also the angle ABC will be 90 degree. So we can apply the Pythagoras theorem, and we can write AC will be equals to square root of AB square plus BC square, which will be square root of BC square. We can write it as L square plus B square, and AB square we can write it as H square. So it is H square plus L square plus B square. After rearranging, we can write it as L square plus B square plus H square. and that will be the length of diagonal of the cuboid. So length of diagonal here will be equals to square root of L square plus B square plus H square. Next, when we talk about cube, so cube is a special type of cuboid. That means when the length, breadth and height of a cuboid becomes equal, a cuboid becomes cube. So in this case, we'll take let L equals to B equals to H of the cuboid as A. So here again, a cube will also have 6 surfaces, and here all the surfaces will be a square. And the area of a square is side squared. So if we'll talk about total surface area, that is TSA of cube, that will be 6A square. Then if you talk about lateral surface area of cube, that will be 4 walls, that is 4A square, which also can be written as 4A into A, that is base perimeter into height. Then when we talk about volume of cube, which will be equals to A cube, and we can write it as A square into A, which will be also base area into height, as here height is nothing but edge length, which is A. And here if you talk about the length of diagonal, which will be equals to a square root of L square plus B square plus H square, that means A square plus A square plus A square, that will be equals to root 3A square, and then we can write it as root 3 times A. Next, let's talk about cylinder of height H and the base radius R. So here in this case, the curved surface area will be equals to this area, which will be 2 pi RH. As we know that when we cut along the height to the cylinder and when we see it, it will be a rectangle, and area of rectangle is length into breadth. Here the perimeter of the circular part is 2 pi r and height is h, so it will be 2 pi rh, which also we can write it as base perimeter into height. Next is when we talk about total surface area, which also we say TSA, and here curved surface area is represented as CSA. So the value of total surface area will be curved surface area plus top area plus base area. As top and base are circle and area of circle is pi r square, we'll get the total surface area as curved surface area is 2 pi rh plus pi r square plus pi r square, which will be 2 pi rh plus 2 pi r square. On taking 2 pi r common, we will get h plus r, so it is 2 pi r into h plus r. Next, when we talk about volume of cylinder, that will be pi r square h, which also we can write it as base area into height. So the same logic applies to the cube, cuboid and cylinder for lateral or curved surface area and the volume. As in both the cases, for lateral surface area or curved surface area, we are using base perimeter into height, and for volume we are using base area into height. Next, we'll talk about the hollow cylinder. So in this case, if you will take the height of the cylinder as h, and as it is a hollow cylinder, it will have two circular ends. One will be the inner and the other will be the outer. So let us suppose the inner radius be a small r and the outer radius be capital R, then when we talk about curved surface area of it, which will be curved surface area which is outer plus curved surface area which is inner. Then outer curved surface area will be equals to 2 pi capital R into h plus inner curved surface area will be 2 pi RH. On taking common, we can write it as 2 pi h into R plus R. One more thing here, we need to know about the thickness of the cylinder. So here if you talk about the thickness, if we have here the inner radius R and let us suppose the thickness is T, what we'll observe here is that R plus T, that will be equals to external radius, and so the thickness which we are representing here by T will be equals to capital R minus small r. So here we can write thickness is capital R minus small r. Next, if you talk about total surface area, then that will be curved surface area plus area of base plus top area. Now if you observe the area of top and base, then we'll find it is a circular path where we have to find this particular area, as the area of this path will be outer circle area minus inner circle area. So this will be pi capital R square minus small r square. So we can write it as curved surface area which is 2 pi h into R plus R, and plus area of base and top both will be same, so we can write it as 2 pi R square minus R square. As when we add the base area and top area, it will become 2 times pi into R square minus R square. Next, when we talk about volume, so volume will be outer volume minus inner volume, and volume of cylinder is pi r square h, so outer volume will be pi capital R square h minus inner volume will be pi small r square h, which will be pi h into R square minus R square. Now one thing we need to remember here as a note, that when it is required, we can use the identity a square minus b square in order to solve R square minus small r square, which can be written as capital R plus small r into capital R minus small r. So this is the formula related to hollow cylinder. Now we do not need to remember all these formula exactly this way, as we'll be discussing the question based on the combination of solids. So it is very important that we understand each part of these combinations. Next is the cone. So let's talk about cone as we already know about it. So here let us suppose the height of the cone is h, the slant height is L, and the radius is R. So when we talk about the relationship between L, R and H, as it is forming a right angle, now one more thing we need to remember here, that we'll be talking about the right circular cone or right circular cylinder. That means the angle between height and the radius is 90 degrees. So here when we see that P, O and this point as A, then POA is a right angle triangle. So when we use the Pythagoras theorem, we'll get the first relation as L square equals to H square plus R square, which also can be written as L equals to square root of H square plus R square. Next, we'll talk about the curved surface area of cone, which will be equals to pi r L. When we talk about total surface area of cone, that will be curved surface area plus base area. Here the base is circle and whose area is pi r square. So we can write it as pi r L plus pi r square. On taking pi r common, we'll get pi r into L plus R. Then volume of cone will be equals to 1 by 3 pi r square h. Now, when you relate to a cone and cylinder having the same radius and height, so what we can write for same radius and height, the volume of cylinder will be equals to 3 times volume of cone, or we can say the volume of cone will be 1/3 of the volume of cylinder. Next we'll talk about sphere. So when we talk about the sphere here, all the surfaces are curved. So when we talk about either the curved surface or total surface area, here it will be same. So when we talk about CSA or TSA of sphere, it will be equals to 4 pi r square. Then volume of sphere will be equals to 4 by 3 pi r cube, where r is the radius of this sphere. Next, we'll talk about hemisphere. So when you cut the sphere into 2 equal halves, each half form a hemisphere. In this case, if we'll take the radius of it as r, here the height of it also will be r only. Now let's talk about the curved surface area of it. So CSA of hemisphere will be equals to 2 pi r square. Then the total surface area of hemisphere will be equals to curved surface area plus area of, you can say, base or top. So that will be 2 pi r square plus pi r square, which is 3 pi r square. And then when we talk about volume of hemisphere, it will be half of the volume of sphere, which means it will be 2 by 3 pi r cube. Next we'll talk about hollow hemisphere. So in this case, if you'll take the inner radius as small r and the outer radius as capital R, then what we'll get is thickness will be equals to capital R minus small r. And now when you talk about curved surface area of it, we'll have curved surface area which will be outer plus curved surface area which will be inner. So outer curved surface area will be equals to 2 pi capital R square, and inner curved surface area will be 2 pi small r square, which we can also write it as 2 pi r square plus r square. Next, when we talk about total surface area, that will be curved surface area plus area of top, or we can say base. So here the base will be again a circular path. So curved surface area, we know it is 2 pi r square plus 2 pi r square, and the base area, where it will be this area, that will be equals to pi into r square minus r square, which we can write it as pi r square minus pi r square. So while adding it, we will get 3 pi capital R square plus pi r square, which will be the total surface area of hemisphere. Next, volume of hemisphere in this case will be the outer volume minus inner volume. So outer volume of hemisphere, which is hollow, will be 2 by 3 pi capital R cube, and the inner volume will be 2 by 3 pi small r cube, which also can be written as 2 by 3 pi r cube minus r cube. Now here again we need to remember the identity, that is a cube minus b cube, which will be a minus b into a square plus ab plus b square, as it can be useful to solve these type of questions. So this is all about the today's session. In the next session, we'll be discussing about the surface area and the volume of combination of solids, where we'll see that how we can analyze and find areas and volumes of combination of solids. Thank you. Take care, everyone.